So on your formula sheet, we talked about this a little bit at the class yesterday. Maybe you noticed I put your quizzes in. We're not getting them back today because some people are writing it now that they're back to class, and there was a couple people still sick that aren't here. So we'll wait for them to write it before we get them back. But you'll see on your Power School that your marks are in. And what we looked at after the quiz was the surface area of a cone. And here is something very cool mathematically, how you notice that the more sides you put on the edge of a pyramid, eventually it turns into a circle. And we take the formula that we had for the lateral area of the pyramid, and we apply that perimeter of the base. When it turns into a circle, it turns into the circumference. And so the surface area of this cone, when you, like, if you bought some kind of, I wonder, do you ever get ice cream cones that have paper on them? I know the McDonald's ones, but they're not pointy. Is there any pointy places that give you paper on them? Right? Yeah. Or if you ever have one of those paper cup things that you pull out of a drink machine, if you cut it down and open it up, it will give you a shape, and that shape would be like, how do I figure out the area of that shape? Well, now we can see it's just 1/2 slant height times the circumference of the base, which simplifies nicely to pi rs. Now, this is not a formula that I would say you memorize because you get this formula on your formula sheet. So the surface area is the lateral area, which we've figured out is the red part, plus the circle at the bottom, which is the pi r squared. A right cone has a base of 4 meters and a height of 10. When drawing things in 3 dimensions, the base of a circle, the base of a cone is a circle, but when you're drawing it in 3 dimensions, does it make sense that you would draw an oval? Right? In fact, on this oval, I'd probably take out I would probably draw the back part with a dotted line, pick a point for your height, so you can draw a 3-dimensional shape that way. It tells us the radius is 4, so the radius goes from the center to the outside. That's 4 meters. If this was an ice cream cone, I would have a very good weekend. Just imagine, I would probably be sick on Monday. 10 meters high, 4 meters as a radius, like that's, let's see, starting from, let's see, 1, 2, 3, 4. So it's from about here to the wall as a that's the radius. Oh, yeah, I would die. And then 10 meters tall is like, you can't even hold that ice cream cone. You just have to build a structure and then have a ladder and just lick all week. It would melt probably. Okay, now we have it. Sometimes it's good to have a visual of what you're working with. There we have the visual of a huge ice cream cone. Calculate the surface area to the nearest meter. So we go to our formula sheet. We have our surface area formula, which is pi rs plus pi r squared. The pi rs is the outside part. The pi r squared is the area of the circle. And we plug in our numbers. We know the radius is 4. And then we run into a problem. We don't have the slant height. What do we have? We have the height, but not the slant height. What is the slant height? That's this line from here to here, the green line. So we need to figure that out. How do we figure that out? We look at the shape. If you have a height, does it make sense that a height is always at a 90 degree? Okay? Right? If they measured my height from the wall to the top of my head at not a 90 degree, I'd be very tall. Right? Because that distance is a lot longer. So when we measure height, it's always at a 90 degree, which gives me a right-angled triangle. What math do you know with right-angled triangles? Right. A squared plus B squared equals C squared. So we get 16 plus 100. 116 equals C squared. Square root both sides, and you get C is equal to the square root of 116. I am just going to make a note that that is an exact value. If I type 116 and the square root into my calculator, I get 10.77. But that is rounded. So now when I go back to the formula to enter in my values, I would put not 10.77 as a number in here. I would leave it as the square root of 116 plus pi, radius is 4 squared. And when I go to my calculator, I would type in pi. Times 4, you can either use brackets like this or do times 4. Times by, and here I would write the square root of 116. Plus pi r squared. So I can type it in exactly the same as I see it, whether I have a graphing calculator or a scientific. Some scientific calculators don't show you what you're typing. Some do. The one, if you bought the scientific calculator from the school, you can see what you're typing. It's really nice that way. That's why I chose to get that one. Yes? Yes. The answers will always expect you to be exact right till the end. So now I push enter. Okay? My answer is exact. Well, it's exact until this decimal place because there would be more decimal places that I can't see. But now when I write my answer, first of all, I might, if it doesn't say, you can choose any decimal places that you like. So I might do 185.61. But then I would reread the question because almost always they tell you what to round to. Some of you lost half marks on your quiz because you didn't reread the question to see how it was supposed to be rounded. So if it said round to the nearest kilometer, but you left a decimal place, then you lost a half a mark, basically for not rereading the question and paying attention to details. Pre-calculus applied math is very focused on attention to details. And because of that focus on attention to details, a lot of professions require math to get into that. If you look at the University of Manitoba, there's an old one up there. I should get a new one, but it basically hasn't changed. They say, you need 60% in pre-calculus math to go into this. Why? Do you need pre-calculus? Do you need to graph? Well, what have you done yet? Well, we've done measurements, right? Do you need to, well, I'll talk about something that's going to come up. You're going to be graphing parabolas in grade 11. Parabolas are U-shaped graphs. You need pre-calculus math to go into nursing. Do you think nurses have to draw parabolas on their patients? No. Okay? But nurses have to have attention to detail. They need to know exactly the medication that's coming to you. It can't be something that they're like, oh, I was close, right? I know I was supposed to give them 1 pill. I gave them 3. Should be okay, right? You'd be a little bit nervous if your nurse was like, yeah, I'm pretty good at the accuracy of the stuff that I give you. You'd be like, no, pretty good isn't good enough. I want you to pay attention to details. So pre-calculus math, it really pays attention to detail. By doing pre-calculus math, you get a skill of paying attention to detail, which is used in a lot of professions. There you go. Okay, so it now says round to the nearest square meter. It's also good that I reread that because I just realized I forgot my units in my answer as well. Here's the Great Pyramid of Giza. The surface area of the triangular faces is 3,000 inches squared. This is just a model. This isn't the real pyramid, right? Because I was like, if the real pyramid was only 50 inches long, they'd be like, that's not a very big pyramid. Again, let's draw a picture. It has a square base. So how do we draw a square in 3 dimensions? With a point up here for the height. The surface area of the triangular faces is 3,000 inches. The side length of the base is 50 inches. Does it make sense that the 3,000 inches squared is equal to the 4 triangles? If you wanted to, then you could find the area of one triangle by dividing by 4. And you would get 750 inches squared. What do we want to find? Determine the height of the model. So I'm going to draw a dot right in the center, and I'm going to put an H in here. And level of difficulty of this question is fairly difficult. Why is it difficult? Because you can't find your answer directly. You have to do some extra steps in between. So how do you problem solve when you need extra steps in between? Okay? 1, you can think about questions that you've done in the past, right? If we look at questions with cones, questions with triangles that we've done in the past, if we go back to, which was it this question right here? We see that sometimes we had to find the height, or this one we had to find the slant height to use it on the sides, and we needed to use a Pythagorean triangle to do that. We look at the question that we're dealing at right now. What do I know? I know areas. I now found the area of one triangle. You ask yourself, well, how do you find the area of a triangle? I have a formula. Base times height divided by 2. So I know that one of these triangles has a base of 50. It has a height. Why am I not going to put H here? Is this, if I put h here, is that the same as this h? No. Technically, this should be an S for a slant height. But I know that the area of this is 750. If you can plug things into a formula where there's only one thing you don't know, you can always find that one thing. If you plug things into a formula and there's two things you don't know, sorry, can't figure them out. Not yet. Okay? So I know the area of this triangle is 750. I know my formula for an area of a triangle is base 50 times height, which is the slant height, divided by 2. Mathematically, we can get the S by itself. What would I do? I would probably, since it's easy mental math, 50 divided by 2, I would probably do that first. 25S. Then, if I want to get S by itself, divide both sides by 25. 750 divided by 25? 30? Is that right? Do you know my trick for dividing by 25? I think about money. I think about quarters. If you had $7.50 and it was all quarters, how many quarters would you have? 30. How do you figure that out? Well, every dollar is 4 quarters. So if you had $7, well, 4 times 7, that's 28 quarters. And then the 50 cents is another 2 quarters, would give me 30 quarters. Mental math tricks. Okay, sorry. We've got S is 30. So now I know that S is 30. Have I solved the question? No. I still need to find the height. But now, my height, could I use this triangle? Do I know everything on that triangle except for the height? I don't know the height. I know my slant height is now 30. Do I know the base of this right angle triangle? 25. How did you figure out the 25? Half of 50. Beautiful. Now, a squared plus b squared equals c squared. Again, be careful. The c squared is always the hypotenuse. So the 30 squared is going to be on that side. 25 squared is 625. H squared, 30 squared is 900. Subtract 625 on both sides. You'll get 275. Square rooting 275 on your calculator. $16.58. And now sounds like a good time to reread the question. Determine the height to the nearest tenth of an inch. Include my units. It won't be squared because we're determining a length. Anytime we determine an area, our units are squared. Anytime that we determine our length, right, our units are normal. You can't say, I just ran 100 meters squared. That does not make sense. Just like, yeah, and once we get to volume, which is the next thing we're going to look at, then we look at units cubed. So we hit a point where now there's questions in our textbook. We're not going to work on those right now. I will end our video here.